Let's go back to the problem where we tried to use a val and I said it's a bad idea and you should use a macro instead, where you want something like a get form that takes a posin and then the name of a field x or y and extracts the name. Trying to make it a macro using define syntax rule will not work. We can match on get with some posin expression and a field, and then we can write some code here that tries to take that field as a symbol and turn it into another symbol, but define syntax rule will replace the get expression with exactly this expression. So we'll end up computing a symbol here and then trying to apply a symbol to a posin, and that just won't work. We need the symbol to be computed at compile time and put in place in the expression that comes in the expansion of get. So the way that we get the ability to do that is to recognize that define syntax actually binds a name, like get, to a compile time function. And when we use syntax rules or syntax ID rules, that is when we say define syntax get syntax rules or something like that, syntax rules is actually a macro that expands to lambda. And when we have a macro like this, define syntax get with a compile time lambda and STX object, right? Then when the macro is used in an expression like this, then this function is called with an STX argument that is something like this S expression. Right? So STX is the use, and then the job of the function is to rearrange that use into some replacement code, and this is the kind of code we would want to produce. Something like the S expression that starts with posin-x. Right? And because this function is a compile time function, it's called to produce a new expression, then it can actually compute that symbol and include it in the result. So here, just to simplify the problem a little bit, we've got a module x that defines x, has a syntax, it has a macro get that's exported to this other macro, and when we use get here, it expands to x, and of course the result is 1 because the macro says x where x means 1, not x where x means 2. Right? Okay, so that's just regular lexical scope working. So as I said, define syntax rule is actually just define syntax get. You can think of it with syntax rules that says convert a get into x. So we could write it this way, and we would get the same thing. But then syntax rules itself is just a function, creates a function that takes a syntax object, and then, well, we return something like quote x. After doing some pattern matching, which I'm just going to skip, we return something like quote x. But it can't be just quote x, because as we saw with a val, if you have a symbol x, you don't really know what environment it should be in. In fact, a macro is not allowed to return just a symbol like this, quote x. You can see I got an error. Received value from syntax expander, right? Syntax expander is this function right here that was supposed to be the value of get. So instead of a symbol x, we do something very similar, but we return a syntax object x, right? Just by using hash quote instead of quote. This time it'll work, and it'll work as before. We got the number 1, not the number 2, because this syntax object here knows where it came from in a way that a symbol doesn't. So when we use a single quote mark, then that is something that produces an S expression that can be a symbol or lists of symbols or lists of lists and so on. But when we use hash quote, we get a syntax object instead of an S expression, which can have something like a symbol inside, but we call it an identifier, a symbol inside of a syntax object.